I want to explain double layers. This is pretty cool. I was just heading out to get some breakfast this morning and I started pondering on it and it came to me. So double layers, what are they? They're exactly what they sound like. They are two layers of a thing. You find these in cell biology, you find them in plasma, you find them everywhere. It literally just means two layers. Well, in plasma, the interesting thing is that double layers form, and one of the layers is more positively charged, and one of the layers is more negatively charged. Now, I had an epiphany earlier this year about why the two layers don't come crashing together, and we can review that video at a later time. But essentially, it's just that all of the particles that make up the double layer are tightly compacted and they can't move. They're at the densest packing. That's the idea of why they don't come crashing together. But that's not the focus of this video. Why do double layers exist? I think it's very, very simple. And honestly, I'm a little embarrassed of how simple it is. Let's take a thing, anything, let's say this marker. And as I draw this marker on the board, you can see that I am a profound artist and I'm doing such a great job. There's our marker. What we're going to do is zoom in on this top edge of the marker. So literally this part right here, okay? We're going to zoom in on that. And we're going to zoom in to the point to where we can see individual atoms. All right? So now, whoop, there's the magic. We've zoomed in and we see atoms. Well, some of these atoms are positively charged. Well, these positive charged atoms don't like each other. Why do they even hang out? Why is there even a surface to this? Well, the simple answer is that we have negative charges who are their neighbors that hang out in between them. So the negative is attracted to positive, positive attracted to negative. Duh! This is very, very simple. But this whole line of atoms forms the boundary of our marker and of anything that is a thing. But now here's where it gets interesting. Let's count the amount of positive and negative charges here. So we got 1, 2, 3, 4, 5, 6 negative charges. 1, 2, 3, 4, 5, 6 positive charges. So let's do this. Is that likely? Well, sure it is. The point I'm trying to make here is that the charges on any surface are not going to be symmetrical. It's not going to be a perfect positive, negative in even numbers. There's going to be more of one than of the other, which means, kids, that if this out here is the air, the charge facing the air in this case is going to be more negative. You see that? Because there's more negative charges facing this way. We don't really care about what's on the internal part of the marker, but we'll draw it out anyway. So as we go down into the body of the marker, we see this same setup. And it's kind of a lattice configuration. You can think of it like that, where positive and negative charges are just joining up to form the body of the marker, right? But that's not the part we're interested in, because we're interested in why a double layer forms, and these aren't necessarily double layers. I know I'm drawing them as lines that look like layers. They're not. It's a lattice, and it's all kind of mangled and not as pretty as I'm drawing it. I'm looking at the interface between the edge of the marker and the air around it, the charge that can develop on this. Because I've done experiments in here that I have posted before about how we see charges developing on my electroscope that are doing funny things. They're not as clean cut as what I would like to think. And this explains it. So we go back 15 seconds where we talked about the top edge of the marker being more negative. Here's where the magic is. Remember, this space up here is the air around the marker. It's up here. And as I've discussed in previous videos, This air is actually dark mode plasma, which means it has charge associated with it. It has a specific shape, and one of those shapes is double layers. So we have a negative charge showing on the surface. What's going to be attracted to that? Well, duh, it's going to be positive charges. We're going to have more positive charges attracted to the layer of the pen. And just to keep this easy to understand, there's the surface of the marker, right? Here's the marker. Remember how we zoomed in on the marker? That's the body of the marker. But we have positive charges naturally accruing on the top of that. Well, what's attracted to positive charges? Duh, negative charges. That is not a negative symbol. We have negative charges. Oops, I'm still drawing that in. We have negative charges attracted to the positive. Now, I granted this as slightly oversimplified, but you see it. Look, kids, and there it is. There are our double layers. Remember back from the first video when I drew it, that a double layer is two layers of charge, and one of the layers is more positively charged, and the other layer is more negatively charged? Well, there it is, right there. Double layers are formed because of the geometry of matter. That's it. That's all it is. Ta-da!